You can't stop thinking about them. Every song is about them now. Every notification makes your heart jump. Their name appears on your screen, and suddenly your hands are shaking and you're smiling like an idiot in the middle of a grocery store. You think this is magic, destiny, something the universe designed just for you. But your brain has a different explanation, and once you hear it, you'll never look at love the same way again. The moment you fall in love, your brain begins running a chemical sequence so powerful, so deliberate, and so similar to addiction that scientists have struggled to tell the difference. In the mid-1990s, a biological anthropologist named Helen Fisher at Rutgers University decided to do something no one had done before. She put people who said they were deeply, madly, newly in love into fMRI scanners and watched what lit up inside their brains. What she found changed everything we understood about romantic love. The area that fired most intensely was the ventral tegmental area, or VTA, a tiny cluster of neurons buried deep at the base of your brain. This is the same region that activates when you take a hit of cocaine, when you win a gambling bet, when you get a notification that someone liked your photo. The VTA is your brain's reward system, and when you fall in love, it starts pumping out dopamine at levels you are simply not used to experiencing. Dopamine is the chemical of wanting. It is not the chemical of having. It makes you crave. It makes you obsess. It makes you seek out the person who triggered it with the same desperation a starving person feels toward food. That is why you check their social media at 2 in the morning. That is why you reread their messages looking for clues. That is not weakness. That is dopamine doing exactly what it was designed to do. But dopamine was only the beginning of what Fisher discovered. She also found heightened activity in the caudate nucleus, a brain region involved in goal-directed behavior and pattern recognition. Your brain was literally building a map of this person, their habits, their expressions, their voice, the way they tilt their head when they laugh, and flagging all of it as the most important information in your world. Here is where it gets strange. Fisher and her colleagues also noticed something that was not lighting up. The prefrontal cortex, the front part of your brain responsible for judgment, critical thinking, and long-term planning, was significantly less active. The parts of the brain that would normally ask, is this a good idea? Is this person trustworthy? Am I being rational? Those areas were going quiet. Falling in love, it turns out, is not just about turning things on. It is also about turning things off. Your brain deliberately lowers your capacity for critical judgment so that you can bond with another person without sabotaging yourself with doubt. Now, if the dopamine surge sounds familiar, what comes next will sound even more familiar. In 1999, an Italian psychiatrist named Donatella Mariziti at the University of Pisa studied the serotonin levels of people who had recently fallen in love within the previous 6 months. She compared their blood work to the blood work of people diagnosed with obsessive-compulsive disorder. The results were nearly identical. Both groups had serotonin levels roughly 40% lower than normal. Serotonin is the chemical that helps regulate mood, appetite, and obsessive thought. When it drops, your brain gets stuck in loops. You repeat the same thought over and over. You check and recheck. You cannot let go. That is why you replay a single conversation 40 times. That is why you overanalyze the way they said goodnight. That is why you cannot sleep, cannot eat, cannot focus on anything that is not them. You are not being dramatic. Your brain chemistry has literally shifted into a state that clinicians would recognize as obsessive. The early stage of romantic love and clinical OCD share a biological foundation. Mariziti called this a form of temporary, love-induced madness. Your brain hijacks your ability to move on from a thought, and it points that entire hijacked system at one specific person. You are, in the most literal neurochemical sense, addicted. But your brain is not done yet. There is a second phase of love, one that most people never think about because the first phase is so overwhelming that it feels like it will last forever. It will not. The dopamine storm of early love typically lasts between 12 and 18 months. After that, your brain begins transitioning into a different chemical landscape. Oxytocin and vasopressin start to take over. These are the bonding chemicals. Oxytocin gets released during physical touch, during eye contact, during sex, during long, quiet moments of just being near someone you trust. Vasopressin, a closely related hormone, is associated with pair bonding and protective behavior. In studies on prairie voles, small rodents that form monogamous lifetime bonds. Researchers found that vasopressin was the key chemical difference between species that mate for life and species that do not. You are not a vole, but the chemical architecture is strikingly similar. Oxytocin is why their hug feels different from anyone else's hug. It is why your heart rate drops when they hold your hand during a stressful moment. It is why a 10-second eye contact session with someone you love can make you feel calmer than an hour of meditation. Your brain is using physical closeness to build a chemical foundation for long-term attachment. And this is where another researcher enters the story. In the 1990s, psychologist Arthur Aaron at Stony Brook University began studying what actually creates the feeling of closeness between two people. His famous experiment involved strangers who were paired together and asked to answer 36 increasingly personal questions. By the end, many of the participants reported feeling profoundly connected. Some even fell in love. One pair eventually married. Aaron's work showed that love is not just chemistry. It is also a process of psychological expansion. When you fall in love, your brain begins to merge your sense of self with the other person. Their goals become your goals. Their pain becomes your pain. Their identity slowly folds into yours and yours into theirs. Aaron called this the self-expansion model of love. You literally become a bigger version of yourself through another person. This explains why breakups feel like losing a part of your body. It is not metaphor. Your brain has restructured itself around this person. Their absence creates a gap in your neural architecture, a gap that your brain interprets as genuine loss, the same way it would process physical pain. In 2011, researchers at Columbia University used fMRI to study people looking at photographs of their recent ex-partners after an unwanted breakup. The areas of the brain that activated were the same areas involved in processing physical pain, the anterior insula and the anterior cingulate cortex. Heartbreak is not a poetic exaggeration. Your brain processes romantic loss on the same neural circuitry it uses for a broken bone. So let us put all of this together. You meet someone, dopamine floods your reward system. You feel euphoric, energized, obsessive. Serotonin drops and your brain locks into a loop of constant thought about this one person. Your prefrontal cortex goes quiet and your judgment softens. You do things that your friends find irrational. You make choices you would never normally make. Then if the relationship continues, oxytocin and vasopressin slowly replace the dopamine storm. The obsession fades. The calm deepens. You begin to feel safe. Your sense of self expands to include this other person. You build something quieter, steadier, and in many ways more powerful. But here is the thing your brain does not tell you. The first phase, the addiction phase, is not love. It is attraction. It is a neurological trap designed to get two humans close enough, long enough for the second phase to begin. The euphoria is real. The chemistry is real, but the certainty it gives you is not. Your brain is temporarily suppressing the part of itself that thinks clearly so that you will bond with someone before you have enough information to make a rational decision. This is why so many people confuse intensity with connection. This is why the most passionate beginnings sometimes lead to the most painful endings. Your brain was not showing you who they were. It was showing you a chemical dream and calling it fate. The real work of love begins after the chemicals calm down, after the obsession fades, after your judgment comes back online and you can finally see this person clearly, not as the dopamine-soaked fantasy your brain constructed, but as a full, complicated, imperfect human being who is still choosing to stay. That is the part no one writes songs about. But it is the part that lasts. The next time you feel your hands shake when their name appears on your screen, the next time your heart jumps at a notification, the next time you catch yourself smiling like an idiot in the middle of a grocery store, know this. Your brain is not experiencing magic. It is running one of the most powerful chemical programs it has. And understanding that program does not make the feeling less beautiful. It makes you brave enough to feel it clearly.